Okay, where do you upload it?
Now today I'll upload. Okay, so
No,
I'll
that's fine. Where, like, do you upload it on Gmail account somewhere, or how should we do this?
the data nodes, and actual data is data nodes, and the reference of the data, or you can say metadata, or you can say index of the data in data nodes are written into the name node. Metadata, or you can say index of the data in a data nodes are written into the name node. Now all these data nodes are connected to the master. So this is a cluster of one master node and four slave nodes. Fine. So that is, suppose you are going to write some sample file. So the sample file is written into the data nodes, and the reference of the sample file, which directory where you're writing the file, is written into the name node. Fine. Now a user or a client application is wrote a job. Suppose previously what we did, we have a file, the file name is prod_info.txt, and we wrote this file into the Hadoop cluster. So this file is available in the cluster. Now the client enters a job or a query, or he wrote something like select count from prod info, right? You want to check like how many rows are there, or how many users are there, how many products are there, some job a client executed from his system. Now when a client executes a job, we have a component called job tracker. Okay, what we call it as, it has a job tracker. Now always the job tracker takes the request from the client. Okay, so job tracker resides in a which machine? Job tracker resides in a machine where name node is available. So name node is a one process in one node, and in the same node we are configuring the job tracker. Now whenever client enters a query or a program or a job, that job is accepted by, taken by the job tracker. After that, now job tracker searches in the name node about the location of the file into the data nodes. What you're looking for, prod info is a table where the table is having the data prodinfo.txt, which is distributed into this cluster. Now consider we have this file prodinfo.txt is distributed as four parts, right? Some 25,000 records are in this data node. So next 25,000 records in this data node. Some data is distributed, right? The file prodinfo.txt is distributed to four data nodes. Means some part of data here, some part of the data here, right? Like this we are having the data. Now, job tracker gets the location of the data where the data is available in a data node. Now, remember, we have another component called task tracker. We call it as a task tracker, right? Tracker is a kind of process which executes the job. The job execution is done by the task tracker. So in a name node, we have the job tracker. In the data nodes, we will have the task tracker. Simple question. If somebody will ask you in a cluster, how many name nodes we'll have? We'll have only one name node. How many job trackers we'll have in a cluster? Only one job tracker. How many data nodes we are going to have in a cluster? It depends upon the size of the data, right? So we always keep adding multiple data nodes to the cluster. Disks, four disks are completed. We are going to write five more, one more node, right? So we can have multiple data nodes. And just remember this: every data node will have a one task tracker. So in a cluster, there are 10 data nodes are there. In each data node, we will have a task tracker. So this data node is having one task tracker. This data node is having one task tracker. This data node is having one task tracker. Right? In each data node, we'll have the task tracker. Right? So job tracker resides in the machine where name node is available. Task tracker resides in the machine where data nodes are available. Now, job tracker took the request from the client and goes to the data node where the data is available. Now, job tracker assigns this job to the task tracker. Now, task tracker takes the job from the job tracker. Now, the data is available in the disk, right? Where the data is available in the same place, we are executing the job. Now, this task tracker works with this data and it will give the output back to the job tracker. Then job tracker will send the result back to the user. Suppose as long as job tracker is running the job, sorry, task tracker is running the job tracker is waiting for the task tracker's response. So task tracker will keep sending heartbeats, messages like I am working, please wait. The task tracker until it completes the job, it will send the heartbeats to the job tracker like I am working, please wait. So as long as the job tracker getting the heartbeats from the task tracker, job tracker thinks that okay, task tracker is working with the data and it's going to be processed. Once the task tracker completes the job, then this job output will be given to the job tracker. From the job tracker to it will be given back to the client, right? So this is a name node and some data nodes. So most of the times we configure job tracker in a machine where name node is available. Sometimes in the sense you cannot accommodate that many number of resources in one machine, or you are going to run the multiple giants, you're getting many jobs has to be performed, then we can able to configure job tracker as a separate node. Otherwise, job tracker resides in the machine where name node is available. Task tracker resides in a every data node. So in a cluster, if you are having the 10 data nodes, in each data node, we have one task tracker. If somebody will ask you why Hadoop jobs are faster, the simple answer is because we are executing the job in a place where the data is available. Right, the data available in this node, in the where the disk is having the same machine, we are going to run the job. So this is one reason why Hadoop jobs are executed in a faster way, right? So apart from this name node, we'll have one another node which is also known as a master node. We call this as a secondary name node. Right, what is secondary name node? I'll tell you later. As of now, remember that we'll have a one name node. So that is, if it is a primary name node, then it will be the secondary name node. We'll have one more node that we call it as a secondary name node, right? So the backup, not the complete backup of primary name node, but some data which we are going to write into the name node is also will make it available into the secondary name node. But don't think that secondary name node is a backup node. Secondary name node is not a backup node, right? So what I'll teach you about the secondary name node later, right? As of now, so what are the master nodes in a cluster? What are the master nodes? Name node, master daemons are what are the masters? Name node, job tracker, secondary name node. So this we call it as the master nodes. And what are the slaves? Data nodes and task trackers are the slaves. Client request taken by the job tracker. Then the job tracker searches in the name node, so metadata. to find the location of the data in the data nodes. Then the job tracker goes to that particular data node, and the job tracker will assign the job to the task tracker in that data node. Then task tracker will execute the job. As long as task tracker is executing the job, it will send the heartbeats to the job tracker that I am working, please wait. So once the job is completed, task tracker will give this output back to the job tracker. From the job tracker, the output will be given back to the client. So this is how your job is going to be processed. So this is the Hadoop architecture. I can say like before 2.0, right? So we right, it's something like before 2.0, right? In after 2.0 also we're having the same thing, but the job tracker's role is replaced by the yarn. So after 2.0, that's you can say 2.0 onwards. Only the difference is instead of the job tracker, we are using resource manager. Instead of the job tracker, it is a resource manager. See here, uh, one job tracker is doing how many jobs? Taking the request, searching in the name node, going to the data nodes, assigning the job to the task tracker, listening to the heartbeats from the task tracker, and getting the output from the task tracker, passing the job to the client. So one job tracker is doing this job. So what we did here, suppose it's simple words. Previously, we used to have one employee. We used to take care of all these things. Now we have recruited two employees. When the two people are working, then they are going to distribute the jobs, right? So the same thing now, the job tracker's job is distributed to two processes. One is a resource manager and other one is a application master. Means so the same job tracker, the same job, but it will be distributed to the two people now. Previously, one employee has to do their work. Now the two employees or the two people are working. So how? First, a request is taken by the resource manager. Resource manager takes the request from the client and allocate the resources in the data node. Now uh, after allocating the resources, the execution process taken care by the application master. So now application master is monitoring the job execution. In that time, resource manager can able to take one more request from the client, right? So now resource manager takes the second request and it is going to create resource in the data node. Till that, the application master can able to complete the job one from the task tracker, like this, right? So the same job tracker's role is distributed to the resource manager comma application manager. Now instead of the task tracker, we have something called node manager. Okay, so this is Hadoop 2.0 onwards. In a yard, we used to have resource manager and application master, which are replaced by the replaces the role of roles and responsibilities of a job tracker, and whatever the task tracker is doing, that can be done by the node manager. Okay, so if somebody says what the Hadoop Daemons, now we can say something master and slaves. So name node, data node, secondary name node are the masters and job tracker. And what the slave nodes, data nodes, comma, task trackers are the slave nodes. So this we says before 2.0. Now Hadoop 2.0 onwards, right? 2.0 onwards, we used to have multiple name nodes. We'll have the two name nodes, right? So like in one name node, I'll take one more node as a name node or backup name node. Whatever the data which you are going to write into the name node, I'm also going to write into one more node, one more name node. Means in Hadoop 2.0 we can have multiple name nodes. Means two writes, right? Previously if it's a one name node, so whatever you are writing into the name node will be written. Now in the 2.0 onwards we are going to write one write into the name node. The same write again we are writing into the another name node. That is, we call it as a backup node, or you can say some shared node. So if this name node goes down, immediately we'll make this name node up and run. So that, so we are giving the cluster full and the high availability. That's it, right? So we'll see this later. So we call this as a name node, or some people will call it as a shared node, or some journal node, or quorum node, right? Something, but it will be a backup node. So whatever you are going to write into the name node, the same thing we are going to write into the another node. That's, we call it as a name node. So this is another name node. So in a Hadoop 2.0 onwards, we can have multiple name nodes as the masters. So what are the master nodes? Name node and secondary name node and one shared node. Okay, and do we use a job tracker? We use yar. So when you are using yar, we have resource manager is available, okay, as a master nodes. Now what are the slaves? Same, data nodes are the slaves, and instead of the task tracker we have node manager is known as a slave, right? So always this is like a Hadoop Daemons are the Hadoop processes. So if a cluster is starting, if a cluster is running, means in the cluster both master daemons and slave daemons are running, then we can say that the cluster is started. Suppose if you want to start the Hadoop cluster, means you have to start the master nodes or the master daemons, and then you have to start the slaves daemons. Then we says that, yeah, cluster is started. So in the name node, secondary name node, we are going to store the data, and with the job tracker, task tracker, resource manager, node manager, application master, with these processors are used to process the data, right? Something like if he says that the job processing and the data storage, right? So where we are going to store the data in HDFS, correct? So the dimensions which are related to HDFS means same name node, secondary name node, and the data nodes, right? Suppose if you have a shared node, so these are all the HDFS dimensions. We can call this as a HDFS dimensions. And then what are the MapReduce dimensions? Means suppose you want to start the MapReduce, that is job tracker and task tracker are known as the MapReduce dimensions. MapReduce dimensions in the sense which these are used to run the job. The job execution is done by the MapReduce. Suppose you have started the HDFS, but you have not started the MapReduce. That means we are going to store the data into the cluster, and you have not started the MapReduce. We are unable to run the jobs. Okay, if you want to run a Java program, MapReduce job, if you want to write an Hive query, or if you want to write a pig program, that is, you have to start the MapReduce. So when you are starting the MapReduce, means the job tracker is going to be started into the cluster, and the task tracker is going to be started, right? So if you want to start the yard, want to use the yard in the cluster, then you have to start the resource manager, then you have to start the node manager. So in a cluster, now you can start HDFS and MapReduce, or you can use HDFS and yard. That is, a job is going to be executed either with a mapreduce environment or with a yarn environment, right? So whenever you run a job, if you started the yarn in the cluster, the job is taken by the resource manager and the job is executed by the application manager, monitored by the application manager, where the data is available into the node manager, which is in a data node, and the execution is done in the node manager, and the application master will give the result back to the user in yarn. Okay, so what we do now, so so if you want to start the cluster, so we have to start the HDFS. That is, to start HDFS, we have a file, that is start-dfs.sh is a shell script we are having. We use this script to start the HDFS. So then what this script will do, this script will start the HDFS, that it will start name node, data nodes, secondary name node, shared node, it will start the HDFS. To start the MapReduce, right, we have to use start-mapred.sh. To start your same thing, we have a script file is there, start-yarn.sh to start the yarn. So again, to stop it, to stop the HDFS, we have a script stop-dfs.sh. To stop the MapReduce, the script is stop-mapreduce.sh. To stop the yarn, we have a script stop-yarn.sh. Instead of starting the DFS ones, then starting the MapReduce ones, so we have a script is available, which is start-all.sh, which will start both the Hadoop and the MapReduce. To stop, we have to write stop all.sh, which will start HDFS, MapReduce, and if any other process running, so that also going to be stopped with a script stop-all.sh. Right? So this is about Hadoop daemons or the Hadoop processes.